This presentation was written by Sophie Lytton, Tyrrell, Harriet, Rhodes-Jones and Rosalind, who are all mathematics students at the University of Birmingham. Before people invented the number system that we use today, many ancient civilizations counted using body parts. Using just one hand, you can count to 5, and often anything past this was referred to as many. Eventually, humans began to settle down and grow crops. They would count the number of days until winter using clay tokens in a pot. When the pot was full, they'd know that winter was here. Now, this works fine if you only need to count a handful of animals. But what if you have more than a handful of animals? Or more than that? Eventually, humans would need a way to write down large numbers easily. The ancient Egyptians invented a hieroglyphic numeral system in about 3000 BC. They had several drawings which represented different values. So here you can see that the straight line is a value 1, this horseshoe shape is a value 10, the spiral is 100, and the strange shape is 1000. Now, using these hieroglyphs, they could write down numbers quickly and perform basic arithmetic. So let's have a look at an example. So here we have 10, 10, 10, 10, 100, 100, which when you add them together will give you 240. However, where these values are in the hieroglyph does not matter. We could easily have the hundreds at the start. Now, consider trying to count a number that is significantly larger than the previous example. To write down this number, you need a very large piece of paper. This became a problem as pharaohs, which is the equivalent of today's kings and queens, would need to count how much grain they had, or how many people were living in their kingdoms, and these would be very large numbers. The Babylonians developed a similar system. They used two symbols representing 1 and 10 to make values up to 60. Let's have a look at an example. Okay, so here we have 3 ones, which will give you the value 3. And here we have a 10 and 2 ones, which will give you the value 12. Now let's have a look at a slightly larger number. Here you have 3 10s and 2 ones, which will give you the value 32. Similar to the number system we use today, the Babylonians used place value. So with the decimal number 362, this is broken down into hundreds, tens and ones. A similar system was used with Babylonians, except they used powers of 60. So the first column would be ones, the middle is 60, and the third is 3,600. So let's have a look at how this is actually used. Okay, so in decimal, we have the number 32, which is actually 2 times 1 and 3 times 10. So let's have a look at the Babylonian number 61. So we have 1 times 1, we also have 1 times 60, to give us 61. The Babylonian system is perfect for measuring time, with there being 60 seconds in a minute, 60 minutes in an hour. So let's have a look at some Babylonian time. So let's work out the number of minutes in 3 hours 20. In Babylonian digits. So we have 20 times 1 and 3 times 60, which will give you 200, which is the exact number of minutes in 3 hours 20 minutes. Babylonians were also keen astronomers. They were first to realise that there were 12 lunar months in a year and 30 days in each month. 12 and 30 are factors of 60, which makes the maths work out really nicely. Babylonian astronomy really set the way for modern astronomers today. So, place value works if you have a placeholder. Let's have a look at some confusion that could arise as a result of the Babylonian number system. So, here we have the number 3,601, whereas over here we have the number 3,660. Well, when written out, they look exactly the same. To solve this problem, we need something to hold value. Indian mathematics formed the foundation of the base 10 number system we know today. They labelled the digits 1 through to 9, and although these symbols look unfamiliar, as they moved through the Arab world and into Europe, they became the symbols we recognise today. Most importantly, though, they come up with 0, a placeholder, that solves a problem we had with the Babylonian mathematics. So let's have a look at how 0 helps us with position. So here you can see the numbers 202 and 220. And despite the fact that they have the same combination of symbols, they represent very different values. There's no more ambiguity about which column objects are in. So Indian mathematics allowed you to easily count and write down the number of objects you had, no matter how many goats there were. You can easily write down large values, such as 364,859, as seen here. Nowadays, we mostly use the base 10 number system, first developed in ancient India. We call this a decimal system. However, one number system that is used incredibly frequently is binary. Binary is a base 2 number system and uses only 2 digits, 0 and 1. Chances are you use it every day of your life without even realising. Smartphones, laptops and tablets all count and perform arithmetic in binary. Here is an example of a number represented in binary. So, this is a base 2 number system, so the place value goes up in powers of 2. So to count this number, we have 132, 14 and 12 to give us 38. This is useful because computers can't actually count and they work by sending and receiving digital signals. No signal is represented by 0, and a signal being received is represented by 1. In this way, computers can provide us with long binary strings that will then be translated into numbers that we recognise. Thank you for watching. I hope you enjoyed our presentation.